My name is Donovan Bergin. I work at JB Hunt, and I'm an expert software engineer over the visibility domain. And for those of you who don't know who we are, we'll go ahead and give a little overview of JB Hunt is, what we do, why we're using graphs. We'll jump into kind of what we're doing for infrastructure as code over at JB Hunt to help with our process. So with that being said, let's go ahead and jump right into the presentation. All right, so we here at JB Hunt are always working towards improving our continuous, our CI/CD processes. And one of the things we like is infrastructure as code. So we wanted to kind of toy with different ideas for how to do that. So first I'll talk a little bit, like I said, about what we've done. So there's trucks on a graph, and I'll provide some links once I'm done kind of talking through this stuff. But we gave a presentation at Graph Connect, and among other things, they gave me this cool mug. But we talked about how we're using graphs to track our truck data. We'll do a quick overview here so that you guys can understand what we're doing. Then we'll talk about what we kind of needed, and we'll kind of go through a demo of SchemaSmith and kind of how it helps us with this process. And then we'll talk about what pipelines we have set up in order to kind of help us. So with that being said, let's go ahead and get into JB Hunt, a little bit about what we do and why graphs are important and what kind of problems they solve for us and why we want to make sure they're good graphs. Okay, so our mission statement is to create the most efficient transportation network in North America. So you may see our trucks driving down the street, you may see our trains on the rails, and recently you may see our boats over the ocean. So we've actually succeeded pretty good at this North America thing, and now we're getting into international shipping. But not only that, but we have a vision for sustainability, and that is to kind of push forward with low carbon for a low carbon future. So visibility really helps with those. It's one of the major challenges that we have in the transportation industry. So I'm sure some of you guys have experienced this. Maybe you're tracking your package and all of a sudden it becomes delayed and you have no idea where it is, or it starts going along like its delivery and then it goes back and then forth and you don't know what's going on. So like we all kind of understand this is an issue from a consumption side, but providing that visibility is also important for reducing cost, for being efficient with your carbon-friendly logistics networks and things of that nature. So visibility is kind of important. And logistics, I think we can all understand why that would be a good fit for Graph, right? Because you've got these carriers who are driving the loads. They want to know if they're going in the right place. Is their route efficient? Receivers want to make sure that when the stuff comes that they're able to handle it. But if we have bad visibility, maybe it shows up when they don't expect it. And if we have bad visibility, our shippers and our customers can't trust that things are going to get there when they want, because we've not optimized our networks or our opportunities during the shipping process. But as we increase our visibility, that helps us by ensuring that we can do things like making sure that one of our drivers picks up in Texas at his home, drops off maybe in Florida, and has a pickup there at where he dropped it off to take him back home so he can spend more time with his family rather than trying to scramble and find some random route on his way back. We can take care of that ahead of time. Receivers will know when their product's going to get there, when it's not going to get there, and shippers have a consistent view of what's happening and consistent expectations for their shipping. So once again, some of the things that we focus on, the sustainability, the reduce of carbon emissions. In 2021, we avoided about 3.6 million metric tons of carbon emissions by converting some of our over-the-road networks that's driving on a truck to rail. So we really like to understand what's happening with our networks and with our equipment so that we can optimize our process. And that's why it's really important to have a predictable graph for us to look at so that we can easily identify what we're looking for. So specifically what we're talking about today is how we're monitoring equipment and why it's important to have some data governance around that, right? So we're taking in telemetry data from these equipment, whether they're trailing equipment or the trucks themselves, about their direction, where they're heading, maybe how cold or how hot the cab is. So if you're shipping like beer, you want to know if it's gotten too warm along the journey or if it's too cold or things of that nature. So we want to ingest all that data and represent that in a graph. So I know I've talked a lot about JB Hunt here as a quick overview, but we'll talk about, I promise we're going to talk about infrastructure as code. If you want to learn more, I'll drop a link for a previous talk that goes more in depth about all of these things. Okay, so we'll talk about it in a minute, but what was really cool about the Graph Connect conference is we got to learn about Neo4j4, and some nerd guy walked up on stage and said, for Neo4j, we wanted Neo4j4 to be super boring. And so we said, well, we need a super boring product. That sounds great. We don't want any surprises. And so these are some of the lessons that we learned that made it a little bit too exciting for our taste, that kind of drove us into trying out some different processes around data governance. But how did we start out? We went ahead and took the Neo4j training that's available, and I highly encourage any of you who are considering working with Neo4j, or if you're faking it to make it, their courses for Neo4j and the certifications are really great, and they've helped us to be really successful. Shout out to Rob and Mike, who helped us early in our journey and continue to help us with advice and helping us to be successful in what we're doing. And then we built a boring graph, right? You just got your equipment, you've got an operations kind of graphy stuff that I'm not allowed to talk about today. And this equipment has a device that monitors where it's going and all those things. So it has telemetry readings, which give us location readings and sensor readings, and then device alerts if the voltage is low. But then we might have derived alerts, which tells us contextually, hey, this sensor reading is showing a temperature that's too high or too low, or we're going in the wrong direction, something of that nature. So we deployed originally, and it was a super boring deployment. There were no errors in Dynatrace. I'm thinking everything's going great. And then someone kind of leans over and says, well, you know, it's going so well, we have no errors because nothing is writing to the database. And we said, well, that's weird. So we turned on our logging, and we figured out that what had happened was our applications, our microservices that were running in order to write data were running under editor, but they couldn't create new nodes because there was no nodes in production. There was no relationships. And so Neo4j says, whoa, hold up, you're an editor, can't do that. So we thought, easy button, make all our apps publisher, life is going to be great and back to boring. So we fixed that problem. And then say a couple weeks later, there's a PR for one of our microservices, and we want to start putting Pokemon in our graph because I have to give examples that aren't our real code. And so I'm looking at this PR, I'm saying, yeah, that looks good. We'll put some Pokemon in our graph. And let's say like there's another listener that needs to do the same thing, but they're not using a shared library. Maybe they're in different languages or something like that. And so I would start reviewing another one that also needs to add, Pokemon to the database on Friday. I'm saying, looks pretty good. All right, let's write those Pokemon. I'm going to we have a successful deployment. I go have a good weekend, and I show up on Monday, and there's an issue. And that is that some of our Pokemon have individual value ratings that are off the charts. Others have individual values ratings because there was a typo. So, it's individual values. Values has very little use for us when we're trying to query. If you're trying to say, okay, if I'm looking for Pokemon in my zone that are where their individual value ratings are close to mine, but you've typoed your property and your application has publisher access, well, then all of a sudden it's hard to get visibility because you've gone and messed up your data model. So we end up in the situation where my app needs to run as editor so it doesn't make junk data, but my app also needs to run as publisher to initialize entities in my database or properties and things of that nature. And so we start thinking, well, how can we solve this issue to protect ourselves in the future? and allow developers freedom, all of those good things that come with schema optional databases. And so we're like, well, wait a minute, maybe I can take my data, I can create a script, I can put it in a CR, which has an open text field, and then hand that off to another team, the database administrators, to run it. And then after they run it, they can make sure it works. But if it doesn't work, maybe parts of it work, maybe parts of it don't. But if it does work, how do they know it works? I'm like, I don't know, call APOC meta schema and see if the properties are there. And then I've got to define what properties they're looking for. It's just kind of this cycle of copy pasta, human error, nothing's tracked, and it gets crazy. So we're going to go ahead and demo SchemaSmith and kind of why we're using it. And we'll go over the pipelines and stuff. So for those of you who don't know, I do work at JB Hunt, which I've already stated, so you should know that by now. But when I'm bored on the weekends, I like to code, and I like to code for graphs. So I've actually created a micro RM for .NET, which I presented at the last conference. And now on my weekends, I built a tool called SchemaSmith. And these are available on GitHub. And if I can remember my, look at that. If I can remember my hotkeys properly, I can get you right to what we're supposed to be talking about. All right, so let's kind of go through, make sure I've got Neo4j. It's running in Docker Compose right now. And I've got an editor and an admin, right? So we're going to kind of make sure that this problem is happening and that we solve it with this tool, right? So I'm going to go ahead and disconnect and reconnect as the editor so that hopefully I don't have any typos. It's super cold in my room, and cold hands are not good for typing, as most of you guys know. So let's say I want to go ahead and create some nodes and some relationships in my database. And boy, Bluetooth mice. Sometimes it's the demo curse, you know? They just stop working. But we're gonna make it happen. There we go. All right. So as you can see, I'm gonna try to run this, and it's gonna say, hey, you can't make new labels because you're an editor. So we know that this issue is here. All I really want to do is make some Pokemon stuff in my database. So let's look at how we can use the tool to help us. So if we go over here, so this is the GitHub repo for the project, and we can install this tool globally and then use it via the SchemaSmith command. And we'll kind of take a look at the different commands that we can use and how it can help us to port our graph over and represent it as we go through the process. Okay, so here I have a blank project here. And one of the things I'm going to do is, if we look back over here, to assist building with schemas, you can reference the schema found here. It's a link to the JSON schema. So if you're using an IDE or an editor, you can set up its settings such that it will allow you to specify a schema. So I'm going to set up a schema rules. I'm going to reference that link so that when we start building our schema, we'll get auto completion and suggestions and things of that nature, so that I can represent my graph pleasantly in free, sweet free YAML format. So as we're going here, we're just going to look a little bit at this tool. Let me see, did I uninstall it or not before the demo? I don't know. Oh, it looks like I can't spell. Cold hands. There we go. So we're, as you see, we're in alpha. We're in, like, breaking changes are coming, and it's fine. So if we want to know what this does, we've got different commands. We can lint a schema that we're going to build, and we're going to build the graph that we want to write to. We can script out cipher statements, and then you could run those in your own shell or something like that, or you can run it with this tool. And then it also provides the ability to introspect a schema that already exists. So if you don't have one, you can kind of look at it and start your schema from there. All right. So let's go ahead and get started. We're going to add a file, and we're going to call it Pokemon.neoschema.yml, which I believe gives us the rules that we need. And I'm just going to get rid of the command line right now because it's kind of muddying up the space. All right, so control space, I already have autocomplete suggestions, and I also have too small font. So we're going to make that a little bit bigger, right? So my graph has a name. It's the Neo4j graph. I can't autocomplete well because I'm an architect, developer. I called myself out. Okay. So we obviously want to model those nodes. And we've got autocomplete here based off of that schema thing. So I've got label. We wanted to make Pokemon. And then we wanted properties, a name. Let's see, we wanted ID and a type of string. And this just kind of helps with documenting on the intent of your data types, right? But as we all know, it's kind of optional. So you can still do whatever types you want. Like this is just going to make our process of getting these things able to be created by an editor easier and helps us have like a visual representation of our intent for our graph, right? So there's a number type, and we're getting autocomplete based off of data types that are the Neo4j data types. We've got a name for our Pokemon, and that's just going to be a string. And we've got, let's see what else we got. We got level. Oops, name, level. Type, that's going to be an integer. And then we have moves, which is type list string. Now, I'm also going to do something. So if you go through the style guides for naming your entities, your properties should be camel cased or snake cased. Your nodes labels should be Pascal cased. So I'm going to make a few errors here so that we can see it, you know, popping up and complaining at us through the linting process. Now, the other thing we want is relationships, and the type we wanted battled, I think is what we wanted to put it in there. And the properties, let's say we've got a, let's look over here, a date that the battle occurred. Type is going to be date time. And we'll do the outcome as a string. And now we are going to specify kind of the connections that we want. So Pokemon can battle other Pokemon. All right. And we'll take questions at the end. I think I was supposed to tell you guys that at the beginning, but we're going through. That's going to be fine. So we got our relationships. And just for fun, we'll go ahead and put a constraint on there. And we'll say this is a type of node key. And we'll give it a name. And that name will be Pokemon. We'll do something where like Pokemon unique or node key, right? The entity, it's going to be on the Pokemon node, and it's going to be on the ID property. So you see we got autocomplete on all of that. And we're able to kind of quickly express our graph and how we want to use it. So let's go ahead and pull up our trusted command line, clear it out, zoom it in. Sometimes it'd be like that. Okay, this should be a little bit more clear. So we're going to go SchemaSmith, and we are going to say lint the file of, let's see, where am I? I want to make sure I'm in the right. Oops, did that again. Look at me. Demo time. ls cd nodes. Boom, ls. I think we like this. Okay, so now we're good. SchemaSmith lint f Pokemon neoschema.yaml. Boom. All right, so it's already complaining at us for some issues, and it's giving us the line numbers where the issues are. So I expected camel case or snake case, but I found, I don't know, it could be any one of these cases over on moves at 1419. So I go over to line 1419 or column 19, and I change that so that it's proper. And then it's saying that my relationship should be that. And if I'm missing properties, I have extra properties. It complains about that too. But in the interest of time, we'll just kind of keep going. So now if I were to lint this schema, it looks good. It checks out. So now I've got my schema, but I need to generate my script so that I can push my schema into my database and then remove the junk data that I create for it, because I don't really want to create Pokemon if they're not real. And then my editor has access. So I'm going to go ahead and clear this out, and we're going to say SchemaSmith. And we are going to say script, and we are going to give it the file of Pokemon Neo Schema. We are going to give it the server, and let me copy and paste that over because I'm really bad at remembering if it's, the curse of the mouse. I'm really bad at remembering if it's 7678 or 78765431. My username is going to be Neo4j, and my password is going to be connect. And we are going to see if this works. Uh-oh, we messed up something. I needed a Oh, I'm scripting. I'm not running the script, so I gave it too many arguments. I'm just creating a script. I don't need to tell it what the database is. There we go. All right. So we'll open up this, and as we can see, we got a script created, which is going to use the database. It's going to create the constraint for us. It's going to create these nodes with properties with random values. It's going to create the relationships, and when it's done, it's going to remove everything, all the dummy data it created. Okay. So now we can go back to our thing here, and we can say the same thing. Did it over here, but this time we'll say, instead of script, we'll say run script. It's supposed to be more exciting than that. We'll see if that ran properly or not. Usually it outputs stuff when it does it, which makes me think that maybe I goofed something. But we'll find out pretty quick. Yep, I goofed something. So SchemaSmith help. Help me. Okay, SchemaSmith run script, and the file will be Pokemon schema. And then, actually, let's make sure I don't mess this up, because it's bad to mess it up once and twice and 3 times. Okay, so now I've got all my arguments that I need. Run script, and I will look for the file, which will be Pokemon, the server, which should be this, the username, which should be Neo4j, the password, which should be connect, and nothing happens. Well, this is exciting and embarrassing. I ran through this 3 times before the demo, and of course, once you do a demo, it never works out. And here's why: because user error, duh. I created a script, and I'm trying to run not the script. It helps to have the right file. So I created the script, which we see at the top of the screen. We see it in our Explorer, and then I told it to run not a Cypher script. And note to the developer, throw an error for that to the user so they don't embarrass themselves on stage, right? Now we're going to run some Cypher. All right. now we're good. Bada boom, bada bing. We got it. Let's see if it's in the database. Match in, and we'll return that. And look at that. We got Pikachu battling Bulbasaur, and he won. He was victorious. So, all right. So that's how the tool works. And now let's talk a little bit about how we're using that tool within our pipelines to make our lives easier. Because I hope that you can see now that it kind of solves that chicken and the egg problem. It makes sure that your scripts are dependable, and it gives you a visual representation of the graph that's easy to read. So those are all wins, and those all kind of coincide with my PowerPoint presentation, which is super confused about what it's supposed to be doing right now. So if you give me just a moment. PowerPoint, where'd you go? All right, we're almost there, guys. I almost got this fixed. Let me make sure we're on the right slide. It just had a wee bit of an error earlier when I was messing up my hotkeys. We're doing it live. All right. There we go. Now we're cooking. So what we wanted to do is we didn't want to have any manual CRs. We didn't want to have that copy pasta issue. We wanted a schema that's easy to review and approve. We want to verify the scripts before running and tie each script to a release. So what does that look like? Well, it looks a little like this. We have a repo for our different graphs, right? And as a developer, I have a new graph that I want to do, or maybe I already started with a graph and I can run the self-service introspection pipeline, which runs. I didn't mess up the hotkeys that time, guys. So if I were to say run schema, actually we just take pretty much the last script, except the only thing that I'm going to do here is I am going to say introspect, and I'm going to give it a database name of Neo4j, and it's going to create some YAML for me. And what we can see here is that it actually created what we just created. For the most part, it gets a little verbose around here on the connections because technically Pokemon are connected to Pokemon. So it's like the same label, but like twice. But you could clean this up to look how you wanted. And it's going to have everything that you ended up creating on that side. So if you're trying to start this from a project that already has a graph, well, at least there's a starting spot. Okay. So you raise a PR, you can review the changes to that YAML in the script, which gets generated as part of the build process. You merge that PR, which gets released to dev and test automatically, and you can set a date for that for your prod release and have that released for you at that time automatically as well. We do a lot of work, or we do, our SREs and CI/CD folks do a lot of work around ensuring that we have like anytime release stuff and things of that nature. So we're constantly trying to improve and make that a fun and excitingly boring way to do stuff. All right, so what does that schema repository look like? So it's not the real one. Once again, legally kind of stuff, but this may be what a repository might look like if you were trying to do Pokemon and Star Wars products, right? So whether you're doing this on ADO or you're doing it on Amazon or you're doing it on GCP, you're doing it on Git Actions, it probably looks similar. We like writing our stuff in YAML, so we're hopefully used to that. Basically we got our templates, which are generating the cipher, running that introspection. If a dev wants to start with a graph that doesn't have one, maybe you have that update graph YAML which we're going to look at. Then you have, your different graphs, your Galar Neo schema, your Kanto Neo schema, your Pokemon schemas, your Star Wars schemas based on the trilogy and the prequel memes. And so it might look something like this, where you've got a couple of variables, like you're going to say, hey, give me the path of the schemas that I have, and use a template, right, for generate cipher. That template will probably look something like what's below the comment line, which is basically doing, hey, I'm going to install .NET 6, I'm going to install SchemaSmith, and then I'm going to lint and generate scripts. And I'm just going to go to that directory, loop through everything in the directory, and run SchemaSmith script and output the script, and then publish those scripts as a pipeline artifact, which then you can review as part of your pull review process. So what that does is you get to see the diffs in the YAML, so you can easily see what someone is doing to change your graph and what their intent is from the developer standpoint. And since this is all automated, it's not really holding our developers back, because you can always do super experimental stuff locally on Docker Compose or with test containers in your tests. And then you have this same process that you do for your code for your graph structure. So it provides some freedom for the developers, and that automated release to dev and test, and the gated release to prod. So you know what to expect, you know what you're reviewing, and you still give your developers freedom, and your apps still get to be editor, which is fun. And then you can look at the pipeline artifact to see the script that it created. And then if it creates something that's wonky, then you can go back through a manual process. But at least you have the double verification of both of those steps to ensure that you're going forward in the way that you want to. Now, there are some features that I'm planning on adding to this, as far as managing your granular permissions for a role that's not part of the schema yet. And the option of having kind of like right now it's non-destructive, but the option of making it destructive. So I got rid of an index in my YAML schema. So when I generate my script, I want to make sure that I get rid of indexes that maybe I got rid of in my YAML and things of that nature. So there's that's some of the feedback that we've been going through internally that we think will be beneficial, and that I'll be working on as well. And with that being said, that kind of wraps it up. I'll go ahead and look if there are any questions in the chat to see what we have. Love it, love it. Public policy. All right, I'm not seeing any questions, but if I miss one, feel free to type it in the comments and we can address as necessary. I'll provide just a couple minutes because we have a couple minutes left in the presentation. And if we don't, anybody want like a bonus demo? 3, 2, 1. Okay, we got 3 minutes. So bonus demo time. Because why not? Go back to our screen share. Okay, so we've got this solution here. Ooh, all right. Let's go ahead and manage our NuGet packages. And we are going to pull in Grapher. Huh? I know it's somewhere in here. There we go. Go ahead and install that bad boy. We won't get all the way through this demo. When I was practice, I could get it under 4 minutes, and we only have 2 minutes left. But now that you have your schema up and running, you can start building your apps quickly. And if you're doing it in .NET, you can use grapher.neo4j or the community drivers or the driver itself. But this just kind of simplifies it a little bit. So at least in my opinion, so if I go to builder.services.add neographer, and what does it take? It takes it takes it takes the builder. No, not that builder, buddy. Configuration, and I think it takes like the name of your settings. I don't really go into the settings, but we'll take some arguments, and it's fun. And then you can start creating your class, and we'll call this our Pokemon class. And I can make this a node, a neo node. There we go. So this is now a node. Its label is Pokemon. And I can do stuff like add a neo prop for, and if you've done Java like the SDN, this probably looks pretty familiar. But basically you can express your properties and your relationships pretty easily. We're basically out of time. But you know, I've proven, if not anything, that I don't know how to deal with open space on a timeline. So, but if you want to know more, I'm going to drop in the links in the chat, and but I can't do that, I don't think. I'll try to drop those links. And other than that, thank you very much, and we'll see you next time.